Problem 116, chapter 2 is a good example for polar coordinate. In this problem, we have this radar which is tracking this helicopter. The helicopter is starting to fly from here, and it goes with a constant acceleration on this straight line. And this radar is tracking it all the time, right? So, how the radar is tracking and why polar coordinate is the best option for radars, because radar, the way the radar works, it measures the distance of the object from itself, and also it has this angle as well. So it's actually using polar coordinate to work. So all the time it is measuring r and also theta, and from there it can find the location of the object, velocity of it, and also acceleration of it. So in this specific problem, the helicopter starts from rest, and it goes with a constant acceleration here. And at this moment, when the height is 40 meter, and theta is equal to 40 degree, and this distance is given as well, 160 meter. It is asking, and also we have the velocity too. V at this moment is given to velocity is 28 meter per second at this moment. And it is asking for r dot, r double dot, theta dot, theta double dot. So of course we need to use polar coordinate to find r dot, r double dot, theta double dot, right? So first we need to define the direction of ER and E theta. So this is going to be ER direction in the direction of R, and perpendicular to it and in the direction of increasing theta, we have E theta. So if I project the velocity in these two directions, I'm going to have VR and V theta. And VR is R dot. V theta is R theta dot, right? So let me write those equations. We know VR is R dot, and V theta is equal to R theta dot. So if I know what is VR, V theta, and also if I know what is R, so I'm going to be able to find R dot and theta dot. And I know what is VR and V theta because I know V. It's given. So V in the direction of theta, or V theta, is velocity times cosine of this angle. And V times cosine of this angle is going to be VR in the negative direction. Okay, so to find these components VR and V theta, I need to know one of these angles, this one or this one, because I need to project velocity in these two directions. I also need to know what is R. So let's start with this. Let's call this angle, for example, psi, a Greek letter, and also this is R. Let's find these values. For R, we have this H. It is given 40 meter, and also we know theta. So R is going to be equal to H divided by sine of theta, right? Because R times sine of theta is H, so R is going to be H divided by sine of theta. So let's start with that. R is going to be equal to H divided by sine of theta. 40 divided by sine of 40 is going to be 62.2 meter. And to find this angle plus this angle is equal to 180. And we know sum of this angle plus this two is 180, which means psi is going to be equal to theta plus this angle. Let's call this angle phi. So if I find what is phi, then I can add phi to 40, which is going to be psi, right? So let's find psi. How we can find this psi? If I know this distance, sine of psi is going to be 40 divided to that distance. So I need to find this distance as well. And also I'm going to need it to calculate the acceleration later. You're going to see too. So let's find S. To find S, we have different options, but probably law of cosine is the most straightforward way, because I know what is r, I know what is d, I know what is theta, so I'm going to be able to find s. S squared is going to be equal to r squared plus d squared minus 2 times r d cosine of the angle between them, cosine of theta. And if you put the numbers, s is going to be equal to 119.2 meter. And from there now I can find phi. Phi is going to be equal to sine inverse of h divided by s, which is going to be equal to 19.6 degree. So after finding phi, now I know psi is going to be equal to phi plus theta, so it's going to be 59.6 degree. That's it. So after finding this, so now I know I can calculate VR and V theta. VR is going to be equal to the projection of the velocity in the radial direction is going to be VR times cosine of psi in the negative direction. So VR is negative the given velocity times cosine of psi, which we know based on this equation is going to be equal to r dot. So from here, r dot is going to be negative 28 meter per second times cosine of 59.6. So r dot is going to be equal to negative 14 plus 70 meter per second. That's r dot. Now, to find theta dot, I'm going to use this equation, right? So I need to find what is v theta. And again, v theta is going to be the projection of the velocity in the e theta direction. So I need to multiply to the cosine of this angle or sine of psi. So v theta, which is equal to v times sine of psi, is equal to r times theta dot. And from here we can find theta dot, because I know what is v, I know what is psi, I know what is r. So it's going to be v sine of psi divided by r, which is going to be equal to 0.388 radian per second. The unit is going to be radian per second always. Now, the second part of the question is about accelerations. I need to find r double dot and theta double dot. And the equations that these variables show up in them are acceleration in the radial direction and acceleration in the theta direction. Based on previous videos, AR is r double dot minus r theta dot squared. So if I know what is AR, then because I know what is r and theta dot, I'm going to be able to find r double dot. And a theta is r theta double dot plus Coriolis acceleration to r dot theta dot. Again, if I know what is a theta, I'm going to be able to find theta double dot because I know the rest of variables. So this helicopter is moving just on this straight line. So acceleration of it must be again on this line, right? So acceleration of the helicopter, the total acceleration of it, we know is going to be on this line. But we don't know the magnitude of it. We need to find that. But after finding A, I can project it like that velocity in the radial and theta direction to find AR and A theta. But what is acceleration of the helicopter? We know it's starting to move from here with constant acceleration, and we know at this point the velocity of it is 28. So what I have this distance, I have the velocity. At this point, I know the initial velocity. What I'm trying to find is acceleration. If you look at the equations for constant acceleration, with this information, you're going to figure out the best equation for this is using that time-independent equation. We know velocity at this point, let's call it just v. V squared minus initial velocity squared, which is 0, is equal to 2 times acceleration times displacement, which is just s. And from here, acceleration is going to be equal to velocity squared, which is 28, divided by 2 times s, which we found it here, 2 times 119.2, which is going to be equal to 3.29 meter per second square. Now, after finding acceleration, I'm going to be able to find acceleration in the radial and theta direction. The projection of the acceleration in the radial direction, first of all, is going to be in the negative direction, so it's negative, and the value of it is going to be a times cosine of psi. So AR is equal to acceleration, negative acceleration times cosine of psi, which is equal to r double dot minus r theta dot squared. I know acceleration now, I know what is psi, r, theta dot, I know all of them. So I can find r double dot. R double dot is gonna be negative a times cosine of psi plus r theta dot squared, which is gonna be equal to 7.71 meter per second square. And in the same way for theta direction, acceleration in the theta direction is going to be equal to a times sine of psi, and it's going to be in the positive direction. And we know this is equal to r theta double dot plus 2r dot theta dot. I know a psi r dot theta dot r, so I know everything except theta dot here, so I can find it. Theta dot is going to be equal to a sine of psi minus 2r dot theta dot all divided by r. And if you put the numbers, you're going to see theta double dot is going to be equal to 0.222 radian per second square.